Professor Lynn Margulis.
The blue-green algae are still here, even though now they're relegated to a position of relative inconspicuousness. In fact, you can just see them as a kind of scum on the rocks there. They're still around. If you look carefully down there, you can see that there are bubbles coming up out of the water. Well, the bubbles are just the oxygen. And that's just the oxygen that was responsible, that is oxygen given off by blue-green algae. It was the oxygen that was responsible for the transition of the entire atmosphere. The atmosphere went from something very anaerobic, no oxygen at all, to the present level of about 20% oxygen, something like 2,000 million years ago, plus or minus 100 million years. And it's just those blue-green algae, that is their ancestors, of course, that led to that transition. So one can imagine that early scene where blue-green algae were giving off this enormous pollutant, that is oxygen, into the atmosphere and poisoning just about everything around them. One of the ways of coping with the increased oxygen back then, and a way I think that was very important in the origin of the complex cells, was by symbiosis. Now, what do we mean? Two bacteria, very different kinds of bacteria, probably got together and ended up using the oxygen. The first of these bacteria simply broke down sugars and in fact couldn't use the oxygen at all. The second took the breakdown products and with oxygen burnt them essentially and derived a lot of energy from that. And the two together made a complex. And this complex, after a long period of time and many, many changes, became a very successful kind of organism. And in fact, it's that kind of organism that is the ancestor to all the higher cells. The things that were once bacteria, after time, became the mitochondria that we find in all of our cells, all the plant cells, all the animal cells, and even all the fungal cells.